This morning, your alarm went off. You opened your eyes. You assumed you simply went from asleep to awake in one single instant. But that is not what happened. In the final seconds before you woke up, your brain went through one of the strangest sequences it ever performs. A hidden surge, a flood of chemicals, a controlled electrical storm. And you experienced none of it. Your brain works hard to keep this part invisible. Why? Your brain does not flip a switch. It climbs a ladder. Each rung activates a different region, in a different order, at a different speed. Right now, picture the last hour before your alarm rang. You were likely in REM sleep, the stage where your eyes move rapidly beneath closed lids and your brain is almost as active as when you're awake. Dr. Matthew Walker, a sleep scientist at UC Berkeley, has spent decades studying this stage. He found that REM sleep is when your brain consolidates memory and processes emotion. It is also the stage your brain is most reluctant to leave. So your brain delays. In the final stretch of sleep, a part of your brainstem called the reticular activating system begins to stir. Think of it as your brain's ignition switch. It does not turn everything on at once. It tests each system first. Heart rate rises slightly. Breathing quickens. Blood pressure climbs. Your body prepares for movement before your mind prepares for thought. Then something curious happens. Your brain releases a sudden spike of cortisol, the hormone most people associate with stress. Researchers call this the cortisol awakening response. A study published in Psychoneuroendocrinology found that cortisol levels surge nearly 50% in the 30 minutes surrounding waking, and that this surge is sharper on weekdays than weekends. Your body, it turns out, anticipates your schedule before you're even conscious of it. Why would your brain choose stress as a wake-up tool? Because cortisol is fast. It crosses into the brain quickly and sharpens alertness within minutes. Evolution did not design you to wake up gently. It designed you to wake up ready. For most of human history, waking slowly could mean missing a predator, a storm, or a narrow window to gather food before the heat of the day. Your ancestors who woke up fast and alert outlived the ones who didn't. But here is the strange part. While your body is preparing for action, your mind is still locked out of the process. Neuroscientist Dr. Daniel Kripke has studied what's called sleep inertia, the groggy, disoriented state many people feel right after waking. He found that during this window, the prefrontal cortex, the part of your brain responsible for decision-making and self-control, is the last region to fully reactivate. It can take 15 to 30 minutes to come back online completely. This is why you might agree to things in those first few minutes that you wouldn't agree to an hour later. It's why your first thoughts after waking can feel foggy, disconnected, almost like they belong to someone else. Your brain, in those final seconds before waking, is essentially booting up in stages, like an old computer. The engine starts. The lights flicker. But the operating system isn't fully loaded yet. Now picture the moment just before your eyes open. Your brain has already begun increasing activity in the visual cortex, even while your eyelids are still closed. It is preparing to process light before you ever see it. Some researchers believe this is why people often report a brief flash of color or pattern in the instant before waking. Your visual system rehearses, like an actor running lines moments before stepping on stage. At the same time, your hippocampus, the brain's memory hub, begins reactivating. This is partly why dreams from just before waking feel sharper and easier to recall than dreams from earlier in the night. You are not remembering more dreams. You are remembering the only ones your brain bothered to save. Dr. Matthew Walker's research suggests that memory consolidation slows dramatically as you approach waking, which means the dream content closest to your alarm gets a kind of priority storage. It is the last thing filed away before the system shuts the archive. So when you wake up mid-dream, startled, breathless, trying to hold onto a fading image, that is not random. That is your brain interrupted mid-task, caught in the act of organizing a memory it didn't finish saving. Here is where it gets even stranger. Your brain does not wait for daylight or sound to begin this process. A study from the University of Lübeck found that participants who were told they would be woken up at a specific time showed elevated cortisol levels in the hour leading up to that exact moment, even without any external cue. Your brain appears to track time even while unconscious, quietly preparing your body for an event your mind hasn't consciously registered yet. Some researchers believe this links back to your circadian rhythm, the internal clock regulated by a tiny brain structure called the suprachiasmatic nucleus. This structure tracks light, darkness, and time of day with extraordinary precision, syncing nearly every system in your body, hours before you ever open your eyes. In other words, you don't wake up because your alarm rings. In a sense, your alarm is often just confirming what your brain already started. This raises an uncomfortable question. If your brain is making decisions, preparing your body, and reactivating key regions in a specific order, all before you are conscious, then how much of you is actually present in those final seconds? Some neuroscientists argue that consciousness itself isn't a switch, but a gradient, a sliding scale your brain moves along slowly, region by region, until enough systems are online for you to feel like a unified self again. There may be no single instant where you become awake. There is only a threshold, crossed quietly, somewhere in the dark. Which means every morning, your brain assembles you from pieces. Memory comes first, then alertness, then judgment, then identity, then a sense of time, one by one, like instruments tuning before a performance begins. And by the time you're checking your phone, you've already forgotten the performance happened at all. Tonight, when you fall asleep, your brain will begin this sequence again, quietly, invisibly, hours before your alarm makes a sound. It already knows roughly when you'll wake. It is already getting ready. This morning, your alarm went off. You opened your eyes. You assumed you simply went from asleep to awake in one single instant. You didn't. You were built, piece by piece, in the dark, long before you ever noticed you were home.